Hello, this is Mr. Collier, and today we're doing X on Y regression. Okay, so normally when you do linear regression, you get an equation like y equals mx plus b that minimizes the residuals, okay, but these vertical residuals, if you will, the distance or the squares of the residuals, but the squares of these vertical residuals. But you can also have an equation where we minimize the horizontal distance from the point to the regression line. So this squares of these residuals. Okay, and what it creates is an equation that's better for predicting x values when you have y values. Okay, so it's not appropriate to substitute a y value into a y on x regression line to estimate for x, or it's not as accurate as if you did it on an x on y regression line. Okay, so let's take a look at an example, and let's type in this data into the HP prime calculator. Okay, so I'm just going to go to two variable statistics, and let me clear the data. And let's type it in, making sure I don't have a typo. Okay, and next 4, 5, 4, 6, 5, 6, 4, 9, 6, 10, 9, 10. Okay, I think there's no typo. And then to get the y on x regression line, we go to symbol. Oh, they're already reversed. I wanted to put this as C1 and C2 in the order that I typed it in. Okay, make sure it says linear. Sometimes you want to click plot so the data, we have a scatter plot, so you can see there's a positive correlation, but oh yeah, so that made it better. So sometimes you have to click plot and then go back to symbol to see the updated regression line. So this is the y on x regression line. Let's say it's y equals 0.764x plus 1.92. And I'm going to skip down to number D here now. So find the predicted TOK score, so that's y, given that we have an x value of x basically. So we use this equation. So I just substituted 9. Is that right there? That's supposed to be 1.92. Okay, but I just want to illustrate that you can copy and paste this equation by going Shift, copy. I think that works. Wait. I think just calculator version is a bit glitchy. Oops. Let's go back to symbol. Okay, we can copy that. So copy, and then go back to here, paste. Paste is right there in blue. And then you can just simply put in the 9, so you get a more accurate answer if you do this copy and paste. Looks like about 8.79. Okay, so we just used the y on x regression line in order to predict a y value given an x value. But if we want to do it the other way around, we are going to have to do an x on y regression line. So technically your HP prime doesn't do that, but you simply need to switch the C2 and the C1 here. Okay, and now if I click plot and then symbol, I will get a x. This is an x on y regression line. Okay, so this is important to note that the calculator shows an x here, but you just write that as a y. So the x on y regression line is x equals 0.902 y plus 0.139. Okay, so that's the x on y. So if you make a prediction given a TOK score of 8, so that's the y value is 8. So we can just kind of copy and paste here again. So shift, copy, and then escape. Let's paste, and we can stick in 8 here, and we get 7.35. So x equals 0.902 times 8 plus 0.139, and that gives us about 7.35. Now, show both lines on a scatter plot. I'll just illustrate something. So you're going to have two different lines with different slopes, but they will always go through the mean point. Okay, so sometimes that comes up on IB questions, like what point do they both go through? So you can just find the mean point on the calculator, and you'll know the point that they both go through. Now I think I should have done this before. You got to be a little bit careful because your calculator doesn't actually do x on y, so it's better for us to do that from the regular y on x version. So we go to two variable statistics, stats, and this is the mean point. Okay, 6.5. So it does go through 6.5. It always goes through the mean point. Both equations go through the mean point. And by the way, if you go and find the r value, you get same r value both times. But they're two different equations with two different slopes that go through the same mean point.